Hello and welcome back to Getting Started with BGFX. So in this video we are going to be reading a color. So this is useful for, say you want to enable the user to select a game object by clicking on it. Now to figure out which object they clicked on, you can implement spatial partitioning, something like a quad tree, and then that will narrow down your searches. And then from there you can figure out which one they clicked on. But that will only really work with regular shapes. You still have to take into account irregular shapes, irregular polygons. But there is another technique called color picking, and that's where this red color comes in. What you do is you have a second color attachment on your frame buffer, you have a second color in your vertex, and that second color is the ID of your game object, because remember, a color is an unsigned 32-bit integer, so you can have whatever you want in there. You can have any number, and the second color attachment won't be rendered to the screen, so the user won't see it. And when they click on it, you get the pixel coordinates, and then you read the color from that second color attachment, and from there you get the object ID. And you can have any shape you want, because it will it's like rendering the game object itself, except it's just using the game object's ID instead of a regular color that you can see. Alright, well, let's dive into some code then. Alright, so if we go into our project, now the first thing we need to do is we need to create a texture that will take the color that we read from the screen. So if we go into our renderer, we'll go into the header file first. We'll just put it down the bottom here. We'll go BGFX : texture handle m_read value destination. Now we need to go into our initialization code, and we'll create it. So we'll go m_read. Don't know why my IntelliSense isn't working. Equals BGFX creates texture 2D. This is just going to be 1 pixel wide, no MIPS. We'll give it the texture format, so it's BGFX texture format. This is going to be RGBA8. So this has 4 channels, red, green, blue, and each of those has 8 bits behind it. And now we need to give it some flags. So we need to tell this that this is a read value destination and we can read from it. So we go BGFX underscore texture underscore blitz underscore DST, and then we OR it with BGFX underscore texture underscore readback. Okay, so what this means is that blit destination means that it's going to be copied into, and readback means that we can read back from it. Now, why is this complaining? We have to give it the number of layers, which is 0. What else? What else is, oh, sorry, I got those around the wrong way. There we go. Okay, now BGFX doesn't immediately copy the value from whatever coordinates we select. Instead, we are given the frame number when the value will be ready to be read. That means we need to store a variable, need to create a variable to store the current frame number, the frame number in which the value will be read, and a variable to store the read value. So we'll go back into the header. We'll create u ints 32 underscore t m underscore frame. Then we'll do another one, u ints 32 underscore t m underscore read value ready frame, and u ints 32 underscore t m underscore read value. Okay, now we need to initialize them. So we'll go up to the top here, go into our initialize function, we'll go m underscore frame equals 0, m underscore read value ready frame equals, we'll just set it to the maximum possible, 1, 2, 3, 4. There we go. Now we need to create a function to read the value. So create the definition first. Read color. This will take in an X and a Y. Now we need to create the definition itself. So we need to what's called a blitz. That's just copying color. So we'll go BGFX : blitz. Now we need to give it a view ID. So we'll need to create a separate view number for this. So we'll just define it up in our header file. Define. Go blit underscore view, define it as 3. So blit underscore view. Then we give it the texture handle that we need to copy it into, m underscore read value destination. Destination X, destination Y, so those are the coordinates inside our destination texture. So there's only 1 pixel inside our texture, so it's just going, those coordinates going to be 0, 0. Now we need to tell it where we are reading from. So we're reading from our frame buffer. M underscore frame buffer gets color attachment handle. So that's the colors that are going to be displayed on the screen. So it's just everything that we can see. Then we give it the coordinates that we want to read from, so x, y, and the width and the height is just 1, 1. Okay, so now we go m underscore read value ready frame equals BGFX read texture, m underscore read value destination, and m underscore read value. Okay, so what this will do is that the blitz will copy the color from the frame buffer into our texture, and then this will read from our texture and read it into our variable, and this will tell us when the value is going to be ready for us to read. Alright, so now we need a separate function so that we can keep asking the renderer if read color is ready. So we'll make it optional, and of course we need to include optional at the top here. Optional. Now it's going to be u int 32 underscore t, which is the data type for our colors. Okay, now we'll create our definition. So if m underscore frame equals m underscore read value ready frame, so if those two numbers match, that means our color is ready, and we can just return m underscore read value. Otherwise we just return std null option, so nothing will be returned. Alright, now down in our renderer we need to store the frame number. So m underscore frame equals that. So each frame will just be stored here. So it will go from 0 to UN32, whatever the max of that is. You won't reach that. By the time you get to that, you would have closed the application. Okay, so now we want to call the read color function whenever the user clicks on the mouse. So we go up to our main and we go to our event loop. So this will only be called when the mouse button is up and when the user clicks the left mouse button, or release it in this case. So we go STL underscore event underscore mouse button underscore up, and if event dot button equals STL button left. So the left mouse button has just been released, and we also need to check if it's within the bounds of our window. So we go if button dot x is greater than or equal to 0, and event dot button dot y is greater than or equal to 0, and event dot button dot x is less than screen width, and event dot button dot y is less than screen height. Then we just go renderer dot read color event dot button dot x event dot button dot y, and after all that we need to break. Okay, so then we need to keep checking if the read color value is ready. So we can just do it at the end here. So we go std optional uint32 underscore t read color optional equals renderer dot get read color, and if read color optional dot has value equals true, then we'll just get the value read value equals read color optional dot value. Okay, now we need to mask them off. So we want to print the red, green and blue values separately. So we'll go std print line r g b a. So in the 32-bit integer, the red value occupies the least significant bits, so that's the 8 bits on the right hand side, then it goes the green, then the blue, and then the A. So we need to shift those bits. So the first one is going to be read value, and we'll mask off everything else. So we go 0x 1 2 3 ff. Now we need to do the same thing for the green. But then we need to shift it to the right by 8. And then we do the same thing for the blue. Then we shift it by 16. And finally for the alpha, we shift it by 24. Okay, so what is this? So what this does is that it takes the 32-bit unsigned integer and masks off the part that we don't need and shifts those bits to the right so they are within range of 0 to 255. So for example, the green occupies the second most eight least significant bits. So we mask off all those other bits. So we supply this number, we mask it off, and then we shift them to the right to make them the least significant bits. And it's the same for the blue here. It occupies these bits. So we mask off everything else and we need to shift it to the right 16 so that they end up here. And makes them between 0 and 1. Alright, so now we'll run this. And as you can see, we can read the colors. So this part here, this is aqua, so this is green and blue. Over here we've got some purple, so that's red and blue. What have we got here? Over here, a bit of blue. Over here we've got some purple. We can click on our rotating pyramid. As you can see, we get different colors as the pyramid rotates. And that's it for this video. We've only got 2 more videos left in this series. Both of them are to do with text, drawing text to the screen. So in the next video, we are going to be creating a font atlas texture. So I will see you there.